Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm James Titko. Today's chemical query comes from across the pond.
Good morning from Houston, Texas. This is Pamela, and what I've been wondering about is that on Earth, roughly 99% of the element carbon is carbon-12 and 1% is carbon-13. Would chemical elements exhibit the same isotopic distribution on other planets, and what difference would this make?
Thanks, Pamela. Elements from the periodic table are ordered and defined by the number of protons in each of their atoms. This is the atomic number, and for carbon, that's 6. But some atoms vary in the number of neutrons bound up with the protons in their nuclei. These variants are called isotopes, and while isotopes of the same element will share the same atomic number, they have different atomic masses. So as you rightly identify, Pamela, carbon-12, 6 protons, 6 neutrons, and the rarer carbon-13, 6 protons, 7 neutrons, are the stable isotopes here on Earth, meaning that the nuclear force binding together the protons and neutrons is strong, and so they stick around. But why are they distributed in that 99-to-1 ratio? And to your question, Pamela, what about on other planets? Do we see a similar abundance of these same isotopes? Here's Xander Byrne from the University of Cambridge's Institute of Astronomy.
Thanks, James. The short answer is yes. Carbon is made in stars by nuclear fusion, and nuclear fusion has this quirk where odd-numbered isotopes like carbon-13 are generally a lot harder to make than even-numbered isotopes like carbon-12. And because the laws of nuclear physics seem to be the same everywhere in the universe, you will always have a lot more carbon-12 than 13. If you give me a lump of coal and ask me to take out all of the carbon-13, it's actually very difficult because chemically, different isotopes behave almost identically because fundamentally they're still the same element. They actually faced a similar problem during the Manhattan Project because to build a nuclear bomb, you can't just use any old uranium, you need specifically uranium-235. But 99% of uranium, naturally occurring uranium anyway, is 238. So they had to come up with all sorts of clever ways of enriching the uranium to get the isotope that they wanted.
Remember, the only difference between isotopes is their mass. Carbon-13 is a little bit heavier than carbon-12, and this slight difference has big consequences.
Exactly. It makes carbon-13 very slightly lazier, so it doesn't react quite as often. So when plants photosynthesize, taking CO2 out of the atmosphere, they preferentially take in molecules with carbon-12, and as a result, living things have even less carbon-13 than is in the atmosphere. In 2022, the Curiosity rover analysed some rocks in a crater on Mars and barely found any carbon-13, which got people wondering, could this be a signature of life on Mars? But life actually isn't the only thing that can cause this, call it isotope fractionation. There's another possibility, which is that it's just the way that UV light from the sun interacts with the CO2 in Mars's atmosphere. And that would also actually account for this signature. So we need to take some more measurements, look at some more isotopes perhaps, in order to be sure. What's really exciting is that we're finally able to look at isotope ratios in planets outside our own solar system. There was a study last year looking at a planet called VHS 1256b. And because different isotopes absorb slightly different colors of light, by looking at the planet, we can measure how much of each isotope there is. And they found that rather than there being only 1% carbon-13, this particular planet had about 1.5%. Now that might not sound like a huge difference, but that actually tells us quite a lot about the different processes that were going on when this planet was forming. And the fact that the isotope ratio is slightly different from Earth's suggests that other planets might form in quite different ways than the Earth did.
Thanks for the great question, Pamela. A bit of chemistry, biology and astronomy all wrapped up in one there. And thanks also, of course, to Xander Byrne from the University of Cambridge's Institute of Astronomy. Next time we're answering this question from Colin.
If the extinction level event that wiped out the dinosaurs didn't happen and dinosaurs continue to roam the Earth, Would mankind still have risen to be the dominant species on the planet?
Looking forward to that one. Remember to have your say on this and all of our other questions on the forum. Log on to nakedscientists.com/forum. And be sure to drop us a line if you have a question of your own. It's chris@thenakedscientists.com. Until next time, from me, James Titko, thanks for listening and goodbye.
Question of the Week is part of the Naked Scientists podcast. Look us up online at nakedscientists.com.